But no, I know.
I'm joking with you.
Sorry.
Okay. There's no shucks in here either, right? Okay, lesson 1.5. Limits of transcendental functions. And I'll be honest. I'm like, I'm not sure what transcendental functions are. That was my first, okay, it's more limits, basically. That's, we're expanding our limit knowledge, our limit base. So if you research the definition of a transcendental function, you will find this exclamation on Wolfram's math book. A function which is not an algebraic function. In other words, a function which transcends cannot be expressed in terms of algebra. Examples of transcendental functions include the exponential function, trig functions, and the inverse functions of both. So basically, we're looking at exponential functions and trig functions today. Okay? And how that, looking at the limits there. So we're first going to spend some time talking about exponential functions, which I've taught you exponential functions the last 2 years. I don't know if you remember right now what they look like, but we've done them, okay? And in fact, the exponential function y equals e to the x, that's one of your 12, isn't it? You should remember your 12 at all?
Barely. Another sine and cosine and everything.
Yeah. What's e to the x look like? What's the exponential function look like?
In the first quadrant, there's a curve on zero, like curving with 0, 0. Well, the x-y axis. And then in the third quadrant, there's a curve on the x. I don't know.
I think you might be talking about reciprocal.
Is it like?
I think.
Shoot across.
How was that?
It's like it shoots across, following 0, then shoots up.
Yeah. When we talk about exponential, we traditionally think like that. Does that ring some bells? Okay. That's an example of an exponential growth function, right? As opposed to if we reflect it across the y, it's going to be decay. Okay? Yeah.
You know those bracket things that we were talking about 2 days ago?
The double brackets?
The double brackets.
The double brackets?
Is that the same sort of thing as the one function or whatever it was that was like a staircase thing?
No.
Okay.
I think
The step function is what I can't think of the official name of it. Logistic. Right? No.
Is that greatest integer?
Greatest integer. Thank you. My gosh, my mind is. Woo. Okay. But it makes the stair steps. Is that the one you're talking about? Yeah. No, the greatest integer function is just regular square brackets. It's not the double brackets. Good thought though, but okay. So exponential functions. We did this in Algebra 2. We did this in Pre-Cal. They're of the form y equals a times b to the x minus h plus k. Keep in mind h and k are your shifts, right? That minus h is going to take you left or right, opposite the sign, so it won't really matter for limits. Our plus or minus k is going to take you up or down. That can matter. Because keep in mind, what's right underneath here, at the x-axis here, is an asymptote, right? And that could be a limit at times. The b is your base, okay? And that will help us determine if our function is a growth function or a decay function. And your a is more of your stretch compress. It also can be a reflection if it's negative. Okay, so we're going to look at here. Here they provide the equation and the graph. But when we flip to the next page, we're going to want to try and talk about these without the graph. So the idea of do you know enough about the equation to be able to figure out the limit? And you can if you take into account whether it's a growth function or a decay function, whether it's right side up or reflected upside down. You just have to put the pieces together here, okay? So, with that in mind, what did I put on the next page? Okay, I have all 6 on the next page. We'll go there. A. F of x is 3/2 to the x minus 1 and minus 3. So that is a growth function. The minus 3 moved it down 3. Okay. And how do I know just by looking at the equation this is a growth function? What do we know about 3/2? Yeah. Your B value is greater than 1, so that's your 3/2. And so that does indicate this is a growth function. Okay. And then as you look at this graph, it's just a traditional growth function. And I know when I was checking against her notes, she talked a lot about the fact that is this graph then increasing or decreasing? Because that's going to help you understand your limits here. But a traditional growth function does not reflect or anything. This is an increasing graph, isn't it? It is going up. And so that's helpful to think about when we have to sketch a graph and whatnot, okay? So, what about the limit as x approaches negative infinity? What do you think that limit is? As x approaches negative infinity, what y value are we getting closer and closer to? That asymptote, which is -3. And so that is where understanding that that number at the end is your up or down movement is helpful. Okay? As x approaches infinity, so as we go farther off to the right, what value are we getting closer to? Positive infinity, because our y values are going up consistently. And so that is positive infinity. Okay? So again, we're looking at the graphs. Next page, we're going to look at more just the equations. Now, B. As we look at this one, and when we talk about these functions, realize we always want x to be positive as we talk about things, okay? So we still have an x positive. What is my b value here? The b value is just the e, because the negative is officially going to be separated as part of your a value. So as you look at this, my b value is still greater than 1, because remember e is 2.718 or whatever. And so, are you going to argue me if I say this is still a growth function? It is a growth function. But what was done to this growth function? It was reflected, yes? Because right here, a is negative. Because a is negative, that reflected it. And once it got reflected, what did my graph do instead of increasing? It is decreasing. So do you see how I can tell all that just by looking at the equation? That's what I'm trying to get you guys to do here. So, the limit as x approaches negative infinity. As my x values are getting smaller and smaller and smaller, what y values are we getting closer to? 2. And that's because this graph moved up 2. As x approaches positive infinity, so as we go farther off to the right, what y values are we getting closer to? We're going down, so negative infinity. C. Now, when we talk about the b value here, what b value do you currently see? B being the 1 raised to the power, and currently you see 2/3, which is less than 1, which would officially say it's decay. Is this graph decaying? No. And here's where the catch is, do we have a positive exponent though? We don't. So if you think of this as that 2/3, if we separate that -1 from that x, is being raised to a -1. What does a negative exponent do to a fraction? It takes it and flips it, right? If you have a negative exponent, you can just take the whole fraction and flip it. And so this is actually 3/2. Does that jive more with the graph now? Yeah, because 3/2 is a number bigger than 1. And so it's a number bigger than 1, so we expect growth. No reflection. So again, my graph is increasing. Okay, did you answer your limits? The limit as x approaches negative infinity? 1. The limit as x approaches positive infinity? Positive infinity. Okay. Notice these were all growth in this column. Notice as we went to negative infinity, we went along the asymptote. As we went to positive infinity, we were either going to positive or negative infinity, depending if my graph is right side up or upside down. Okay. These examples are officially decay examples. Does that make sense here? B is less than 1, isn't it? It's between 0 and 1. So that is decay. What is the limit as x approaches negative infinity? Where are we going? Positive infinity? Going up, up, and away? What is the limit as x approaches positive infinity? So as we go off to the right, where are we going to follow along? -3. Okay. And this graph I can say two things. We already mentioned the fact that it's decay, and it says decay. But it's also, this graph, it's no longer increasing, it is decreasing. Vocabulary. This came up in, I don't know, the homework to review something the other day. But unbounded versus bounded. You guys remember unbounded versus bounded? It was part of like that real big chapter 1 in pre-calc. But the idea that, like for instance on this graph here, as it goes up, is there ever going to be any boundary here? And the fact that this graph is going to go infinitely up, so it is unbounded above. Now, does it have a bottom point it never goes across? Not a point, I guess I shouldn't use the word point, but there's a bottom place it never goes past, isn't there? So it's bounded below, but unbounded above. I wanted to throw in those bounded, unbounded words so you can kind of remember what they mean. Okay. What do you see on E? It's 1/2, so that is going to be decay because it's less than 1. What about this negative, though, out front? That's what reflects it upside down, right? Obviously, the +2 moved it up and all that, but so is this still a decreasing graph? No, as I trace it from left to right, my y values are now increasing. Okay. What is the limit as x approaches negative infinity? Where's it going? Down to the ground, negative infinity. Limit as x approaches positive infinity. 2, so it's running along that asymptote. Now, my b value looks to be 2. That means this should be growth. However, what do you notice with the 2 here? There's a negative exponent. So if I think of this as 2 to the -1, what's the reciprocal of 2? And that's going to be 1/2. Oh, now does that make sense to be decay? It does. So what's the limit as x approaches negative infinity? Infinity. What's the limit as x approaches positive infinity? -2. Okay, that was the easy version. They gave us the graphs, right? So even though I'm trying to go ahead and talk to you about them a little bit, just to start talking about the b value, the a value, the growth, the increasing, decreasing, the reflections. I'm trying to put that all in your heads, right? So, top of the next page. What just happened? Did you see that? Basically, the end behavior of any exponential function tended towards 3 places. What were my 3 different types of answers? Okay. We had infinity a lot. We also had negative infinity a lot.
And then whatever that last value.
Yeah. It was always a value. The other was a number value, but specifically it was the number value of the horizontal asymptotes. Okay. If you want to think, I heard someone say the last value. So if we're looking at a, b, dx minus h plus k, it's always that k value there. Or I'm just going to say, could you guess what I'm trying to spell there? Holy cow. A horizontal asymptote is what I was attempting to put right there. Okay. Now, those are our three answers. So you know, if you kind of are familiar with that, you can narrow, this is why we can do this without looking at graphs. We learned the following rules without considering the behavior for negative a values. So in other words, assuming a is positive, basically. This is saying if a is positive and b is bigger than 1, then it is a growth, and thus f is increasing. If a is positive, but now b is less than 1, so between 0 and 1, realize that is decay, and as long as we don't have a reflection, f is decreasing. So until you reflect it, increasing and growth go together, and decreasing and decay go together. The decreasing flip-flop when we start reflecting things. Okay? So that's the point here. Growth and decay are not synonymous with increasing, decreasing. Consider the behavior of the function in relation to the horizontal asymptote. Notice whether the function is moving away from or toward the asymptote. And also, what effect does a negative coefficient on x do to the function behavior? We just talked, what's the negative do? Negative coefficient is going to take the graph and reflect it, flip it upside down. Okay. Use the equations from example 1 to complete the table below. So, we've already answered, this is just filling in information based on what we had on the front side. And again, this is all about our exponential function of a times b to the x minus h plus k. Okay. Can we fill these in quickly? I don't know. We have a lot of the information on the front side. Okay, row 1. What's my base? What's my b value? 3/2. Is it increasing or decreasing? You can always flip back to the graph and look too, but this is a growth problem. No reflection, so it's going to increase. If that's the case, in this growth scenario here, what was always happening in the growth scenario as x approached negative infinity? As we go to the left, what are we running alongside? The asymptote. So in this case, that limit would be -3. And then the limit as x approaches infinity, what's this graph doing as it goes off to the right? It's going up because it is a growth graph and it is increasing. You see what I'm saying with that? Okay. Now, what's my base value here? E. Because what is the negative is technically your a value, right? So if a is negative, is this increasing or decreasing? I'm now going to take my growth graph and flip it upside down. So it's decreasing. As x approaches negative infinity then, so it's still growth, right? Except now it's growth upside down. So it's still along that asymptote. As we go off to the left, the idea is with these in this section, it's going to look like one of those two. So as you go off to the left, it's always going to be along an asymptote if it is a growth scenario. And so what's my asymptote here?
2.
The fact that my graph moved up 2. As we go off to the right, my graph is always going to go up or down. This one's reflected and going down, so negative infinity. Let's see, B value is
3 over 2.
Oh, I was writing that in the next box. I didn't know if we've.
Yeah. Officially, your B value,
Adriana Perez, please report to the high school office. Adriana Perez, please report to the high school office.
officially your B value has to have a positive exponent. So because we have this negative exponent here, our B value is 2/3.
Aiden Starr, please report to the high school office. Aiden Starr, report to the high school office.
2/3 to negative 1. But 2/3 to negative 1, better written would be 3/2. Am I making better sense there? Okay. So it is growth for that reason. Am I increasing or decreasing? I'm still increasing because it's positive. So this graph is going to be another right side up one. As x approaches negative infinity, so as we go off to the left, we're running along some asymptote, which is 1, because your graph moves 1 up. And as x approaches positive infinity, we're going to positive infinity. I started thinking, man, we're about ready to get out of class because they're calling people over the intercom, but never mind. Are we following what I did okay here? I feel like I'm going kind of quick. Am I too quick? I mean, here's where I will have to slow down when we get to the examples, right? Which, guess what? Next page. Okay. Keep trying with me. What's my base here? 1/2. It's still a positive x value, so 1/2. 1/2 makes it decay, right? Now, what's a decay one look like? Excuse me. Decay goes, a traditional decay one goes more like that, right? It's reflected across the y-axis is what's happening. So decay is that. And it still has an asymptote running along underneath it. And so now, a traditional decay one is decreasing. Okay? As x approaches negative infinity. So as we go off to the left, is it going to be a number this time? No, this is decay. So it's either going to be going up or down. In this case, we're going to be going up to positive infinity. As x approaches the right, now since it's decay, we're going to be running alongside that asymptote. What is my asymptote? -3. Did you notice my limits kind of flip-flopped here? We went from having numbers here to having infinity. We went from having infinities to having a number. Okay, what about the next one? Okay. Base is what? Still that 1/2, so still a positive x. Increasing or decreasing? Yeah. Normally decay will decrease, but we have an a value here that is negative. So that's going to make it reflect upside down and increase. So instead of being like this, we're going to be like that. I don't know why I struggle to draw these decays so much. I'm having to think way too hard about it. Okay, so with that, and that means there's an asymptote right here, yes? As x approaches negative infinity, where are we going as we approach negative infinity? We're going down y values to negative infinity. What about as x goes to the right? As x goes to positive infinity? You're running alongside that asymptote, which is at 2, because we went 2 up. And What's my base value next? Okay. So it's not just 2 is what I'm hearing, right? Because there's a negative x, so think 2 to the negative 1. When you take the reciprocal of 2, it does become 1/2. It's still a decay graph then. Are we increasing or decreasing? Yeah, it's a traditional decay graph, which goes back to looking more like that. So it's decreasing. As x goes to negative infinity, my graph is going to go up to positive infinity. As x goes to the right, where's my graph going? Alongside the asymptote of -2. Okay. We got to put this all together now. And this is my suggestion when it comes to homework is going to be, don't just lunge for the calculator. Now, am I saying you can't use the calculator? No. It's homework, it's a tool, it's a resource, it's a helpful thing. But my suggestion as we start looking at these next ones is try and process through it how we're doing right now. Okay, gather all your information, schedule a graph if you need to, and then can you graph it and check yourself? See if your reasoning is making sense. That's my suggestion. Okay? So, time to find the limits. The limit as x approaches infinity of this exponential function, yes? Well, can we process through the same way we were? Is this growth or decay? So right there, that b value is less than 1. So this is decay. Is this traditional decay or is it reflected decay? Okay, so A is negative, so it is going to be reflected. And so traditionally decay is decreasing, but because it's reflected, my decay is going to be increasing, right? And I'll have an asymptote above it. It'll look like such. For me, that's enough to know what I'm doing. I don't know if it is for you, though. Does that give you enough of an idea if we can sketch a graph like that? Okay. And I guess I never actually wrote increasing. Doesn't hurt to. So here, as x approaches negative infinity, so as we go left on this graph, where is it going? It's going down to negative infinity. And let me give you a hint before we get too far. What we just did on the previous 2 pages, right? Looking at the graphs, filling in the chart, those were all as x approaches to infinity or negative infinity, right? We have to have a way to work with those, which is why we're trying to visualize the graph. When you get to ones that have numbers to fill in, remember the rule of always try and substitute numbers in first. Okay, I was working through the homework earlier, and I kept messing up because I just kept trying to visualize the graph and everything and not even think about even trying to plug a number in. So, just an FYI. Okay? Let's see, where's B? B is over here. Okay. Talk me through your thoughts on B. What'd you say?
The values could be, like the b value is less than 1.
And why do you say that?
Because the exponent's negative, so that it's going to be 1
Okay. So right here, when this negative x plus 1, think of it as if you factor out negative, it's negative times x minus 1. And so you would put that, because there's a negative x, we are going to think of it as e to the negative 1, which is 1 over e. Well, I know e to the negative 1 is 2.718. When I take the reciprocal, I know it's going to be a decimal. What decimal? I don't know, but it's going to be a decimal. So this is a b less than 1, and this is decay. Increasing or decreasing?
Decreasing.
There's no reflection. It is traditional decay, and traditional decay is going to decrease. So if I think about traditional decay, I'm thinking about going there, and my asymptote is below it. Okay, we want the limit as we approach negative infinity.
Positive.
I agree. Thus, I wrote it down. Ask questions if you have them. Okay, C. What?
Oh wait, no, it's negative.
Just change your mind. This is a negative x, right? So think of it as if you factor out the negative x minus 1. So this is a 3 to the negative 1, which is really going to become 1/3, right? When we do that reciprocal. And so yet again, this is a decay, isn't it? Because b is less than 1, or between 0 and 1 is what I should be saying. It's decay. Is it increasing or decreasing graph? Increasing. Normally decay will decrease, but A is negative, isn't it? So that's going to make it increase. So let's see. Normally decay graph looks like this. If I reflect it, it's going to look like that. And again, if I can get that picture in my head, I can answer these questions. Limit as x approaches positive infinity. It's running alongside that asymptote, which is negative 3. Limit as x approaches infinity on this next one. My goal is to get these next 3 done. Let's see. Growth or decay?
Wait.
I say support her, don't support her, but she's double checking herself here. Okay, so there's a negative here, yes? So if I think 1/3 to the negative 1, well, that's really 3, isn't it? So that makes my b value bigger than 1, which does make this growth. Is it a traditional increasing growth? No, because my a value is negative and tells us to reflect it. So when we reflect it upside down, growth instead of increasing will now be decreasing. So let's see. Growth normally goes like that. I'm going to flip it upside down. Growth looks like, reflected growth looks like that. And as x approaches positive infinity, where are we going? Down? Negative infinity. E. As x approaches 2, limit of e to the x minus 3 minus 1. What do you know? Okay, it's growth. It's increasing, so it's traditional growth. What limit do I need? Limit as x approaches 2. Does just having a sketch of my graph really answer that question? No. Go back and try direct substitution. If I plug 2 in, exactly, e to the 2 minus 3 minus 1. E to the 2 minus 3 is e to the negative 1 minus 1. E to negative 1 is better written as 1 over e minus 1. I could handle this. Or AP. You have people recognize equivalent answers. If I got a common denominator and made it one fraction, common denominator would be E. This would stay 1 minus 1 would have become E over E. So 1 minus E over E. And if we're doing this without a calculator, we're done right there. We're either taking this answer or this answer. Okay? And what about F? Can I just plug it in? I can try it at least. Yeah. Negative 3, so it becomes 3 minus 1 plus 5. So this is 1/2 to the second plus 5. 1/2 squared is going to become 4 plus 5 is 9. No, what did I do wrong?
1/2 squared is 1/4.
Oh my gosh. I flipped it. Sorry. Yeah, 1/4 plus 5. 5.25. Sorry. Don't follow my logic. Thank you. Okay, guys. We'll pick up there on Monday. Feel free to start looking at the homework. See what you can do with some of these limits.